This figure is a rectangle with a right triangle inscribed in it. If AE is 2 units and BE is 8 units, find the area of the triangle. Let's go ahead and solve. First method. To solve this problem, let's recall that the area of a triangle is 1 over 2 times base times height. From the figure, the base of the triangle is equal to the length of the rectangle, that is, CD. And the height is equal to the breadth of the rectangle. CD is equal to 2 plus 8, which is equal to 10. To find the height of the triangle, let the breadth of the rectangle be h. Next, let's consider triangle CDE. Triangle CDE is a right triangle. From Pythagoras Theorem, CD squared is equal to CE squared plus DE squared. Since CD is 10, it follows that 10 squared is equal to CE squared plus DE squared. 10 squared is equal to 100. So, 100 is equal to CE squared plus DE squared. Let this be equation 1. Next, let's consider triangle ADE. Triangle ADE is a right triangle. From Pythagoras Theorem, DE squared is equal to AD squared plus AE squared. AD is equal to H. And AE is equal to 2. It follows that DE squared is equal to H squared plus 2 squared. 2 squared is equal to 4. So, DE squared is equal to H squared plus 4. Let this be equation 2. Next, let's consider triangle BCE. Triangle BCE is a right triangle. From Pythagoras Theorem, CE squared is equal to BC squared plus BE squared. BC is equal to H. And BE is equal to 8. It follows that CE squared is equal to H squared plus 8 squared. 8 squared is equal to 64. So, CE squared is equal to H squared plus 64. Let this be equation 3. Next, we are going to substitute CE with H squared plus 64 and DE with H squared plus 4 in equation 1. Doing so will give us 100 is equal to H squared plus 64 plus H squared plus 4. Collecting like terms will give us 100 minus 64 minus 4 is equal to H squared plus H squared, which will leave us with 32 is equal to 2H squared. Dividing through by 2. 2 will cancel out 2, and 32 divided by 2 is 16. So, we are left with H squared is equal to 16. Taking the square root of both sides will give us H is equal to 4. Now we know the value of the height, let's go ahead and find the area of the triangle. It follows that area of triangle CDE is equal to 1 over 2 times 10 times 4. 4 divided by 2 is 2. And we are left with 1 times 10 times 2, which is equal to 20. Hence, the area of the triangle is equal to 20 square units. Second method. To solve this problem, first let's draw a perpendicular line from E to line CD. Let this point be F. Observe that DF is equal to 2. And CF is equal to 8. Next, let's recall that the area of a triangle is equal to 1 over 2 times base times height. The base of the triangle CD is 2 plus 8, which is equal to 10. To find the height, let's recall the inscribed right triangle theorem, which states that in a right triangle, the altitude drawn from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of these two segments. That is, x is equal to the square root of y times z. From this theorem, it follows that EF is equal to the square root of 2 times 8. 2 times 8 is equal to 16. So, EF is equal to the square root of 16, which is equal to 4. Now we know the height, it follows that the area of triangle CDE is equal to 1 over 2 times 10 times 4. 4 divided by 2 is 2. And we are left with 1 times 10 times 2, which is equal to 20. Hence, the area of the triangle is equal to 20 square units. Thanks for watching. If you liked this video, make sure to subscribe for more.